It is the question number 19 of your exercise. In earlier video we have seen the previous 7 conversions. Now let us see this, that is your 8th conversion from aniline to chlorobenzene. Fine. Now see that the structure of aniline is, over benzene you have NH2, right? This is your aniline. Now you need to convert this to chlorobenzene. So first let us see that it is undergoing diazotization reaction where it is made to react with NaNO2 plus HCl at a temperature of 0 to 5 degrees Celsius, which is very low, 273 to 278 Kelvin. Now we know that it leads to formation of benzene diazonium chloride. This is referred to as a diazotization reaction. This is nothing but BDC, benzene diazonium chloride. Okay, this is, as I said, diazotization process. Fine. Now this BDC, we will make its reaction with, this BDC actually gives lot many compounds. So when it is made to react with cuprous chloride in the presence of HCl, you will see that you will get back chlorobenzene, where your nitrogen is eliminated along with your HCl. Now this reaction is referred to as your Sand-Meyer's reaction. Okay, so that was your product formation, that is chlorobenzene. This is your product, that is your chlorobenzene formed. So 2-step conversion from aniline to chlorobenzene. Now next what we have is 2-chlorobutane to 3,4-dimethyl hexane. Fine. Now here you first have to write the structure of 2-chlorobutane. So let us see that. We write like this. It is CH3, CH, Cl and C2H5. Now carbon 2 here you are having, third carbon is here and fourth carbon is towards left. Okay, so here that is 1, 2, 3 and 4. So 2-chlorobutane is this particular structure. Now from here you can see that they are asking you to form 3,4-dimethyl hexane. Now how do you form that? Fine. So you will see that you are doing its reaction with sodium in the presence of dry ether. Okay. What happens is 2 moles of NaCl will be removed, because I am telling you that you should take here 2 moles of 2-chlorobutane. Now why 2-chlorobutane 2 moles? If you can recall, you have studied something called as Wood's reaction. Okay, where you are taking 2 moles of an alkyl halide, making its reaction with sodium to give you the alkane. So here also you will get 3,4-dimethyl hexane. Now see that this particular part you write it combining 2 ways, right? So this is one part, 1 mole. Now you have taken 2 moles of it. Now see that you are combining it with the other mole this way. Okay, and you have removed this Cl 2 times with Na as 2 times NaCl. This is, as I said, referred to as Wood's reaction. Okay, it's referred to as Wood's reaction. Now students, how it is named as 3,4-dimethyl hexane, let us try to understand that. Now we will take here, these are 2 carbons, 1 and 2 carbon are here, this is 3 carbon, this is 4 carbon, and your 5 and 6 carbon are here. Okay, 1, 2, 3, 4. So you can see on 3rd carbon you are having methyl group, and on 4th carbon also you are having methyl group. So it is, the name is 3,4-dimethyl, and then you have 6 carbon in chain, that's why the name is hexane. So it is said that in Woods reaction, double the number of alkyl product can be formed from alkyl halide when treated with sodium. I hope it is understood. Now let us go to the next conversion, that is 2-methyl 1-propene to 2-chloro 2-methyl-propane. So let us take first 2-methyl 1-propene, how it is written. Now it is propene, so obviously you are having your 1, 2 and 3 carbons, right? But it is propene, so we will take here CH2. Here you are having on to the second carbon the methyl group, so I write 2-methyl, then I'll just try to satisfy the valencies of carbon. So this is your structure of 2-methyl 1-propene. This way 1, 2 and 3. This is 2-methyl 1-propene. Now we make this react with HCl. When you make its reaction with HCl, the double bond here which you are able to see between first and second carbon will open up, and Cl will be added to the second carbon and hydrogen will be added to first carbon. So it is merely your addition reaction taking place across your double bond. Okay, so you can see this structure is 2-chloro, it is 2-chloro 2-methyl-propane, and this was your, as I said, 2-methyl 1-propene. This was one step conversion. Let us go to the next, and that is your ethyl chloride to propanoic acid. Okay, ethyl chloride is written as CH3 CH2 Cl. This is your ethyl chloride. 2 carbons are there with chlorine, ethyl chloride. Now it is to convert to propanoic acid. First step is we will treat it with potassium cyanide in the presence of ethanol. Okay, you will see that your KCl will be removed and CN will be added. So the product which you will be getting would be CH3 CH2 CN, which is referred to as ethyl cyanide or propane nitrile. Okay, propane nitrile or ethyl cyanide. Now we need to form the propanoic acid, so we will see that the CN group is getting converted to carboxylic group. So in the presence of, when you react with H3O plus, you will see that CN group will be getting converted to COOH group. So this is your final product referred to as propanoic acid. Fine.